Hey guys, this video is about water displacement. The main purpose of water displacement is finding the volume of an object. Okay, so some objects are easy, length times width times height, but if you can't find the length, width, and height, like an odd shaped stone or any kind of odd shaped object, you can use water displacement. So water displacement is a process where we use a graduated cylinder containing a known volume of water and then drop the odd shaped object into it. We then can calculate the volume of the object by determining the volume of water displaced. Okay, so here's some variables we're going to look at. V for volume, Vf for final volume, Vi for initial volume. So initial volume is the volume of water you start with. Final volume is the volume that the water will rise to. Okay, so if you step into a tub or a hot tub or a pool, what's going to happen to the water? The water is going to go up. It's going to go from initial volume to final volume. To calculate the volume of the object, you subtract initial volume from final volume. Now, there's a final conversion that takes you, if it's a solid object, because you're going to be using mLs, you can convert mLs to centimeters cubed, which is the volume of a solid object. You can't say a cube has mLs. A cube will have centimeters cubed. Okay, there's a specific unit that goes along with solids. So here you go. Here's a little example. You start out with an initial volume of 150 mLs. You take the stone or some odd shaped object, drop it in, and the water rises to 180. That is your final volume. Okay, so 150 and 180 are your two volumes you're going to be working with. The volume of this stone can be easily calculated. Okay, let me grab my pen. Okay, so it's 150. Your VI equals 150. Your VF equals 180 ml. Okay, so your volume equals 180 minus 150. So your volume equals 30 mLs. Okay. So the volume of the stone, okay, equals 30 centimeters cubed. All right. Now, can multiply this by 1 ml over 1 centimeters cubed. mLs cancel, getting centimeters cubed. Or you just simply change the ml to centimeters cubed. Okay, so the stone is 30 centimeters cubed. Now let's look at another example here. What is the density of a 50-gram stone that was lowered into a graduated cylinder containing 50 mLs of water if the water level rose to 62 mLs? Now in this case, you have the initial and final volumes here. Okay, so here's an example I drew on the board. Okay, you have your initial, which is 50, and your final, which is 62. Okay, now here's our variables that we're looking at. Our mass is 50 grams, given from the problem. Let's calculate the volume. Remember, final minus initial. So it's 62 minus 50, which equals 12 mLs, and we convert that to centimeters cubed because it's a solid object. Okay, once we have our data, we can calculate the density correctly now. We have our mass, which is 50.0 grams, and our volume, which is 12.0 centimeters cubed. So we simply divide our 50 divided by 12, and we get 4.17 grams per centimeters cubed. And that is the density of that solid object. Okay. Now just remember, if you're calculating the density of a liquid, it's going to have mLs in its unit, grams per mLs. In this case, it's a stone. So you just have to be careful, evaluate your answers, and make sure your units are correct. Okay? And that's it for the video. It's a simple little lesson on calculating density. Nothing complex to it at all. All right, guys.